All right, so we're going to talk about section 5.1 of our book was our introduction to trig identities. So we're going to start off with what an identity is. So basically an identity is going to be an equation which is always true. So if we look at this one over here, we could take our x squared minus 9 over x minus 3 and we could turn it into, with some algebra, to x plus 3 by factoring the top and then canceling common terms. If we look at the one down here, we're going to see pretty quickly, if we were to plug in values, that we wouldn't have the same value on both sides. So for this one, if we put in pi over 6 and evaluate sine of pi over 6 and 1 minus cosine of pi over 6, you see that we don't get the same thing, and so it's not an identity. The simplest identity that we could have would be something like this, where I'd have x equals x. That's obviously an identity. And then if we manipulated one side, so if we took the right-hand side, it is something like 2 times 1/2 x, then that's still going to be an identity, as we could turn this side over on the right back into the side on the left. So that's really what we're looking at with these, with this chapter of how do we do some algebraic transformations and turn one side of an equation into another. So in looking at that, we have some identities to start with. These are more kind of definitions than even identities of what we have for sine being 1 over cosecant, and then cosecant being 1 over sine. So we can flip those reciprocal values back and forth. So if we took something that starts with a given value, so in this case we have cotangent of x is defined for us as 2 over 5 root 5, and we're given sine and we want to find cosine. Well, we can use the identity, what is cotangent, cosine over sine. We can plug in some values, so we know that sine is going to be is defined for us given at the top. And then basically after that substitution, we do some algebra and we can figure out cosine. If we want to, we can go back at the end and verify what our that our algebra actually worked by plugging in values. So we plug in sine and cosine, and then we do some simplification, and in the end we should get back the value that we started with, which was our value of cotangent, which was up here. We know we got it right. All right. There's a couple of identities that come from just the way that our triangles work, our right triangles and our circle values. So if I was to take a point on the unit circle, remember that my cosine value is x, my sine value is y. I have a radius, in this case it's 1. This is a right triangle, which means the Pythagorean theorem applies. So I can get y squared plus x squared is r squared, and then I just substitute back in x and y being sine and cosine, and r is 1, and I would get our Pythagorean identity. All right. We write, one thing to pay attention to is when we square sine, we just put the sine squared there. We don't square the angle. What this means is sine of theta times sine of theta, and the same thing with cosine of theta times cosine of theta. So be a little bit careful with the notation there. So we can take that Pythagorean identity over here, and if we divide by cosine on both of these, we would produce our second identity, and then if we divide by sine on everything, we produce our last identity. So these are identities that we're going to use that are going to pop up, but they all come from our Pythagorean identity and then some manipulations on them. All right, so if we had a problem that looked like this, we've been given some information, we've been given something about cosine, we want to figure out different values. We can start by looking at what we know. So we've been given a value for cotangent. All right. We know that cotangent squared plus 1 is cosecant squared from the previous slide. That's one of our Pythagorean identities. And now we're going to plug in some values and see what happens as we work through it. So I get negative 3 squared plus 1 squared is cosecant squared. Negative 3 squared, all right, is 10. So then when I take my square root of both sides, I get plus or minus root 10 is my cosecant value. Now I haven't used some information, so we got to figure out whether it's plus or minus. So if we look at this, this is 1 over sine of theta, and then we need to use the fact that cosine is negative. So we go back to that given that cotangent is cosine over sine. If cosine is negative, sine has to be positive because cotangent is a negative value. So what we get here is that is the positive one is the one that we take, and that's equal to cosecant. And then if we're looking for tangent, we use the fact that it's 1 over cotangent. It's the reciprocal of cotangent, and so we get 1 over -3, and we get -1/3. All right. We also have some identities that are called our cofunction identities, and what this comes down to is the idea of our angles in a triangle, in this case alpha, beta, and 90, always have to add up to 180. So if we were to write that out and then take away 90 from both sides, we get alpha plus beta is 90 degrees. And then if we solve for alpha, we get alpha is 90 minus beta. And so what we do is we can just plug that in there. So I just make a simple substitution where I can get my values for sine of alpha and cosine of beta is this value here. So I just make a substitution in there and it will work out. Oops, sorry, I had that turned around. So if we're making a substitution, what we'd actually substitute would be not for beta. We're making a substitution here where we have beta is 90 minus alpha, and that's what we plug in. And so that's going to allow us to relate those together. All right, and so these are our values here. We just, instead of our degree value, is our radian value of 90 degrees is equal to pi over 2. All right, we can also use the properties of the symmetry of our unit circle by looking at what happens when I take a point and I flip it down. We notice the x value stays the same, but the y value went from positive to negative. And my angle went from a positive angle to a negative reference angle. And so from there, we can get our values where we see that sine of the opposite angle is the opposite of the value, and then cosine of the opposite angle is still the same thing as we're going through this. So I can see that sine of pi over 6 is 1/2, sine of negative pi over 6 is negative 1/2. Cosine of flipping the angle of having a negative angle is not going to change the value of our values over here. All right, and those are given in our properties here for our identities. Again, I know that these look like a lot to remember, but if you just kind of keep track of what it's asking you in terms of both the circle and your triangles, it will make sense. All right, so remember that sine is the opposite, cosine is the same, and then tangent is going to be the opposite as well because sine has that opposite property of it. And we're just looking at ratios of sine and cosine for cotangent and tangent. All right, so our last one here is if we're given a problem, we want to try to relate them together. So I know that I have an identity that looks like this, right? So sine of x, which is what I've been given, is cosine of pi over 2 minus x. I can get that value. Now I want to see, I don't quite have that yet. So I don't have x, I don't have pi minus x. What I have is x minus pi over 2. And so what I need to do is see if I can transform my equation to give me the same thing that's over here. So if I look at this, I can factor out a negative, right? So I have the negative of some angle here, and that's looking more like my identity. And I use the property that we just looked at of cosine of a negative angle doesn't actually change what's happening. So this is going to be the same thing, where taking the opposite of an angle doesn't change my cosine value. Well, that is the identity right here, which means I can make a substitution for sine of x right here in the box, and I've been given a value of that, which is negative 0.37, and that's actually going to work out. So again, with your identities, you want to make sure that you, first off, are using the ones that are there. Think about it in terms of your triangles and your circle, and then look at kind of algebraic manipulations you can make that will allow you to transform what you have into one of the identities.